Let's look at the solutions to these questions then. So question 1 follows on from the example really. Carbon-14 has a half-life of 5,700 years. Sample of bone tissue from caveman frozen in ice is found to have an activity of 15 counts per minute. If a similar sample from a living person would have an activity of 960 counts per minute, how old is the caveman? Well, let's just do our maths. After one half-life, that value is going to half down to 480 counts per minute. After another half-life, that's going to go down to 240. After another half-life, which is halving, divided by 2 each time here, that's going to go down to 120. After another half-life, that's going to go down to 60, then to 30, then to 15, as in the question. Now, the number of half-lives that takes in is 1, 2, 3, 4, 5, 6. So we just take our 5,700 years and multiply by 6, which gives 30 plus 32,100 years. Okay, so why that's tricky, because there's a number of steps. Each of the steps is quite simple, but I would lay it out like that. Next one is a little bit different because we're working backwards. So it says a sample of iodine 131 is used to treat thyroid cancer. The patient needs a 5-gram dose. It has a half-life of 8 days. It takes the isotope 24 days to travel from where we make it to the hospital. How much iodine 131 must the hospital order? How much must leave the factory? We want 5 grams, but it's going to take 24 days for it to get from the factory to there. And the half-life, which is the key thing in all these questions, is 8 days, which means 8 days previous, one half-life ago, there would need to have been 10 grams. 8 days previous to that, there would have to have been twice that amount, 20 grams. And then 8 days previous to that, which is 24 days here, it would have to be twice as much again. So that when we go forwards in times, then in 8 days it would go from 40 to 20, from 20 to 10, and then from 10 to 5. Okay, which would leave us with the correct amount for the patients. The answer to that question is it would need to be 40 grams. Next one. Radon 222 has a half-life of 3.5 days. If building contaminated with it has an activity of 200. How long will it take for the activity to drop to 25, safe level? Starts off at 200. After one half-life, that's going to half. After another half-life, that's going to half again. And after another half-life, it's going to be down to the 25 that we require. If you notice, we have 1, 2, 3 half-lives. Each half-life is 3.5 days. So the total time taken there will be 10.5 days.